On the shark bite, which numbers do we want to see? Do you go over, had questions about? Seeing a lot of 3s and 4s. So we'll do 3 and 4, as well as show 2 and 5 on Desmos. So let's do the Desmos ones first, and then we'll do 3 and 4. So if you were to do this one on Desmos and plot both points, they happen to fall on the same horizontal line. We're just looking for the slope of that line. What would that slope be? So straight across 0. Remember that if you are using Desmos or using the answers from up here, make sure you said or writing use Desmos. Put m equals 0. For number 5, we had to graph the equation x equals 1. So that would be a straight line, straight vertical line at 1. And Desmos could help us figure that part out. Okay. And then we'll do 3. Let's try this again. 0, 9, 1, 3, 1. Oh, they completely disconnected. Cool. Technology is still on break, apparently. 8, 2, 6, 0, 1, 9. Try. Try this one more time and then I'll finish that. I'm going to restart that. So for number 3, this was way back when we were doing exponent rules. So for actual numbers, we're dividing or simplifying. For like bases that we're dividing, we're subtracting the exponents. So 3 over 27 would give us 1/9. 9 minus 4 would give us c to the 5th. 3 minus 7 would give us d to the negative 4th. We can't have negative exponents in our final answer. C to the 5th would stay in the numerator because it's really over 1. D to the 4th would get brought down and become positive. So C to the 5th all over 9D to the 4th would be that final answer for 3. Now that we know what the answer is, we could check it in Desmos, but you couldn't really do anything with this in Desmos until you at least have an answer. So I'll do that really quickly. the original n, I added sliders. I'm going to change the value of c and d, different values, and then put in our final answer, which was c to the 5th over what? 9. And those answers match, so that's how we know we got that right. Right? Questions on that? Right. And then number 4, you have to combine like terms. Be careful with your negative. Remember that's really -1. You have 3x plus 10x minus 12 minus x minus 2. And then combine your like terms. So we have 13x minus x would be 12x minus 14. Should have been your final answer for that.
So once we do this, it just says compound, we don't have to simplify.
It is simplified. So we didn't need
We're
to
not looking
solve.
for x, we're solving.
Correct. We didn't need to solve because there's no equals. Any other questions on 4 or 3 or the other 2 we did? So before we left for spring break, we were talking about solving multi-step inequalities, solving multi-step inequality word problems, solving compound inequalities, the ands, the ors, and then absolute value, which are really just compound inequalities, but there's 2 of them. Today we're going to graph inequalities, so if you need a ruler, feel free to grab one from the colorful tray. You may want to also have 2 different color utensils, or like a color pencil and a pencil, a pen and a pencil, a marker and a pencil, something like that. So if you need color pencils, there's also some in the colorful trays. So the steps for graphing linear inequalities is very much like graphing lines in general. So step 1, write the inequality in slope-intercept form. So if it's already there, you don't have to change it, but if it's not, you need to get it back in slope-intercept form, so that part's the same. But because it's an inequality, the rules are a little different. So if we have a less than or greater than symbol, we're going to use a dashed line, dashed or dotted. And then if it's less than or equal to or greater than or equal to, we'll use a solid line. So the solid line will be like our normal lines, drawing the points, connecting the dots, drawing the line through it. Dash will just have some pieces missing. Then on top of that, we'll also have to shade, because the inequalities talk about solutions. It gives you a lot of solutions. So if we have less than or equal to, we're going to shade below the line. And greater than or equal to, we're going to shade above. So we're going to jump around, do a few examples, and then move on to the next thing. So let's start with number 1. This is a greater than, so we know 2 things. Because it's strictly greater than, it's going to be a dashed line. I'm just writing this so it's good memory for later. And also, we're going to be shading above. So the line part is the same as any other line. Start at your y-intercept with -5. Do your slope of 1/3, up 1 to the right 3 as many times as possible. Down 1 to the left 3 as many times as possible. But before you connect the dots, because it's a dashed line, you could do it 1 of 2 ways. Just draw in dashes or lines in between them. Or you could draw the line and erase some pieces. Either or. Then for the shading piece, the above, if you're not sure which direction that is, look at your y-intercept, draw an arrow up and down. Up would be above, down would be below. So wherever up would be, that's everywhere where we want to shade. So you can make it nice, you can color in every square, you can color in, like I just did, highlight it, whatever. Questions about the graphing piece of this before we talk about the next piece? The next part, we have to see, do these points fall in the shaded area? If they do, they're solutions. If they don't, they're not. So 0, 0. Does that fall in the shaded area? Yes. 0, -5, we're going to come back to that one. 3, -2. Does that one fall in the shaded area? 3, -2. Yes. 5, -6. Does that one fall in the shaded area? So that one cannot be a solution. -7, 3. Does that one fall in the shaded area? Yes. Okay. So now going back to 0, -5, because it falls directly on the line, in most cases, especially if it has a dash line, it will not be a solution. But to check that, we could put these values into your equation and see does it work or not. So -5 is greater than 1/3 times 0 minus 5. And we'll simplify that and see is it a true statement or not. Is -5 greater than -5? No. If it said equal to, then it would work. But because it's not equal to, that does not work. That's not a solution. Give me a couple more points that would be solutions. So look on the shaded area, find one point that would be a solution. Otis? Or wait, I guess we didn't have that.
2 is like
You said 2 and negative what? 3. Okay, that works. Someone give me another one. Someone else give me another one? Positive 2, that works. Someone else give me another one? One, and then one more. Someone else give me another one. Regina. So as long as it falls in the shaded area, it's a solution. If it doesn't, it is not. So you could pick a bunch. Everyone could pick a different one, and everyone would still be right, as long as it falls in there. Questions on how to graph or how to find the solutions? We're going to skip 2 and go on to the next page. Let's do 5. So before anything, this is not in slope-intercept form, so we have to get it there. How do we get that back in slope-intercept form? How do we solve it?
Then we divide each side every 1. And we get y equals x.
Not equals.
And it is greater than or equal to. So
But what happens when we divide or multiply by a negative? The sign changes. So that's something you have to worry about and remember when you are solving these. So y is now less than or equal to x minus 8. So let's graph that. I think 8 is off the graph, just put it at the end. It'll be like down here. That's okay. Right, and then slope of 1, so up 1, right 1 as many times as possible. I didn't do this, but I can do it now. This is less than or equal to, so that's going to be a solid line shaded below. Of course, you writing those words is not necessary, but if it helps you, continue to do that. So solid line, I'm just going to connect the dots like I would a normal line. Draw arrows again. If this were a dashed line, because the points are so close together, I wouldn't want you to draw tiny dashes in between. You could just make that a dotted line and draw arrows at the end. Right. This one's shaded below. If I draw up and down arrows at the y-intercept, below would be this area. And then someone who didn't answer earlier, tell me one order pair that would fall in this shaded area that would be a solution. Emma? 6 negative. If you thought of a different one, you could put that. For solid lines, if you have points that fall on the line, those would be solutions because you'll get equal to when you go to put them back in.
it's -6.
-6 would work.
Sorry, my brain
It's okay. Right. Other questions on that? We're going to do these last two and then move on. So these two are just like your Hoy bucks when we were graphing. We want to write that off to the side just so we remember what they are. Horizontal lines, 0 slope, y equals, or in this case y inequalities, and then vertical lines, undefined slope, x equals, or in this case x inequalities. Would this be a dash or a solid line? Solid, because it's the equal to. And then if it's less than or equal to, is that going to be shaded above or below the line? Below. So with our y's, it's really easy to see above and below. The x's is a little bit different, but we'll talk about that. So horizontal line at -4, put a point at -4, draw a solid line straight across. It's shaded below, so directly below the line. Someone different, tell me one ordered pair that would be a solution for this one. And in general, because these graphs keep going on forever and ever, this would extend to positive and negative infinity. So if I said 100, -7, that would work. If I said 1,000,000, -8, that would work. But when we write our solutions, we want to be able to see that that solution would actually fit on the graph. Great. And then for number 8, would this be dashed or solid? Dash. And then shaded above or below? So above because it's greater than. It's going to be a vertical line at 6. So you can start to make dashed lines going straight up and down. So above for x is weird. You have to think about, would the numbers to the right be above or would the numbers to the left be above? So would 0 be greater than 6? No. Would 7 be greater than 6? Yes. So that's the area we're going to shade. Someone different, give me one ordered pair that would be a solution. Give me one that would be a solution. Basically 7 anything would be a solution. Okay. Questions on how we graph inequalities and find solutions? Now we're going to do the opposite. Now we're going to be given graphs and have to write the equations, so go on to the next page. So the steps are kind of the same. We're going to be writing our equations in slope-intercept form. We have to find what the slope and y-intercept are so we can use them in our inequality. We have to determine what type of line we're given so that we know what type of symbol to use. And we have to see where it's shaded to see which direction symbol we're using. Right. Solid ones are easier. Dashed ones are a little bit challenging. So let's do 1 and then we'll do 2 and then we'll do a couple more and then switch gears. So let's find our slope and y-intercept first. Y-intercept is probably easier. Where does this line cross the y-axis? I'm just going to put that off to the side. The 8 and the 6 do look similar, but it is 8. And then to find our slope, we have to find another point that would cross the line exactly. The only problem is some of the points are missing, or some of the line is missing, so you have to see, does that pattern follow all the way through? So find another point maybe on the actual dashed lines itself that crosses the grid lines. Regina? Yes. So if we count the slope, that's down 1, 2, 3, 4, to the right 2. So that would simplify to 2. So let's see if that follows. If we go down 2 to the right 1, everywhere, is that our slope? And it seems to be yes. So if you don't make sure the slope follows all the way through, you could assume it's some number, but it's actually not, and then your line is off. So just be careful with that. Okay, so we have our slope, we have our y-intercept. This is a dashed line, so it's either going to be less than or greater than. If we're looking at our y-intercept and I draw an up and down arrow, is that shaded above it or below it? Above it. So that has to be greater than. So that would be y is greater than 2x plus b. Questions on that before we continue? Two is going to be a little bit easier because we don't have to guess the slope. The line is there all the way through. So what is your y-intercept here? -4. Slope as you're going along, what is that slope? 1. You're going up 1, right 1 as many times as possible. This is a solid line, so it's either less than or equal to or greater than or equal to. At your y-intercept, is it shaded above or below it? Or below. Which means it has to be less than or equal to. So y is less than or equal to 1x, or just x, minus 4. Questions on that? And go on to the next page. We're going to do a y and an x. So I'll let you guys choose. 5 or 6. 6, and then we'll do 8. So for 6, we have to know what type of line is given. It's a horizontal, so that has to be a y. So if you want to write your $4 on the side, you can. It's a solid line, so it has to be less than or greater than, less than or equal to, or greater than or equal to. And the value is at -9. Is this shaded above or below? Below. So y is less than or equal to -9. And that's questions on that one? For 8, it's vertical, so that has to be an x. It's also a solid line. So less than or equal to, or greater than or equal to. The number the line is at -2. So is it shaded above -2 or below it. I did that backwards, but yes, below it. So also less than or equal to. If you're not sure, or because it's left and right that confuses you, pick some numbers and say, is -5 less than -2 or is it greater than? And that will help you. Questions on how to write linear inequalities? There is one last thing we have to talk about today, and that is systems of inequalities, where we'll be graphing two on the same graph. So for systems, it's basically the same thing we were just doing. Graphing the lines, talking about the dashed or solid lines, the shaded above, shaded below. But like I said earlier, we're going to be doing two of them at the same time. So we're going to do the one at the very bottom. So the order doesn't matter. You'll eventually need to solve this one and graph it, and then graph this one. So whether you graph this one and then solve and graph, or solve and graph first, doesn't matter. I'm going to use two different colors for these so that we can keep them separate. And I'm going to solve this one first. If you start graphing the other one first, that's fine. So add 3x to both sides. And divide everything by 5. Y is less than 3 over 5x plus 2. And then we can graph that one. Is that one going to be dashed or solid? Dash. Shaded above or below? It is less than. Is that above the line or below the line? Below. So start at positive 2, go up 3 to the right 5, down 3 to the left 5, and then you can draw dashes in between, arrows at the end. Below the line would be underneath, so this area here. And then we'll do the other one. So I would use a different color or something. If you're just using the same like pencil, try to make your shading look different, or maybe one darker or something like that. So this one, would this be dashed or solid? Solid. Shaded above or below? So start at -5. Slope is -2, so up to left 1 as many times as possible. Down to right 1. Connect all your points. above for this one, if I'm drawing in my up and down arrows, would be to the right. If you're using two different colors, then it's easy to see where they overlap. But the goal is to find where the two shading solution sets overlap. If you're using just one color or maybe making one darker, you may want to highlight this area. To show that this is the solution to the system of inequalities. And then we can look and see do these points that they gave us fall within that shaded area, the combined overlapping. Because if they fall in just one but not the other, it's not a solution. So -2, -2. Would that one fall in the shaded area? No, it's like right outside. It like almost made the cut, but it. 1, -1. Change that color. I thought you could see that, but I don't know if that was there. Would that be a solution? Yes, it falls in the shaded area. 1, 1. Yes. 2, 5. Would that one? No. And 6, 0. Would that one? Okay. Just like when you're graphing just one, if it falls on, like if it fell right here in the middle, or if it fell on just the dashed line, you would want to check it to make sure it works or not, because it could work for the solid line, but not for the dashed line. And if it doesn't work for both, it's not a solution. So always make sure you're checking. What questions do we have on how to graph or find solutions of systems?
So they both have to, if it goes on the dash line, it still means it's in the set.
Let's find a point and see. Let's choose this point right here. What was that? 2, 0, 2. I say where you have space, let's check this point and see does it work or does it not. So we're going to put this point into both equations. You can either put it into this one or the one we solved, does not matter. I'm going to just put it in the one that was original. So -3 times 2, times 0, plus 5 times 2 is less than 10. So is this part a true statement? Is 10 less than 10? No. So then that cannot be a solution. So if it falls on the dash line, even though it's in the area, it already doesn't work for the dash line.
And then if you have a solid line, it's
Yeah. So any point that falls on this solid line should work for both. We can test that. 0, -5. It will already work for the solid line, so let's just check this one. -3 times 0 plus 5 times -5. I don't know what that was. Is -25 less than 10? Yes, so that works. So it just depends. And always check. Unless you have two solid lines, then you don't need to check. It'll be a solution always. Other questions? on to the next page. The first two are not, well, the first one's shaded-ish, but the second one is not really, so it should be shaded here. And if you need to see the bottom ones, I'll show you those as well. Because you can kind of see it, but not at the same time. So we're just going to do one of these, and then I'm going to show you how you can check yourself in Desmos, and then you'll have time to practice. We're going to do number 2. If you need me to go back to 3 and 4, I'll do that in a moment. So we have to state the system of inequalities, so this is just like the writing, but twice, and state a solution. Order doesn't matter. I'm going to highlight these so we can kind of tell the difference. Blue one's easier, so let's do that one first. What is the y-intercept of this line? Three. Then we just have to find the slope. So find another point that crosses the grid line exactly. It looks like that's at 2. Mine's a little long. Yours should also be at 2. So solid line has to be less than or equal to or greater than or equal to. At your y-intercept, is that shaded above or below? Is it down here? It's above, so greater than or equal to. So that blue line's equation would just be y is greater than or equal to 2x plus 3. And then we can do the purple one. So let's find the y-intercept of that first. I know it's really small, so use your eyes to the best of your ability. And then our slope, it looks like it goes up 1, left 1, but just to make sure, I'm going to put a point at each one and see if that's the pattern all the way through. And it does. Sometimes it'll look like the slope is 1 or -1, but it'll really be like 2/3 or 4/5 or something like that. It's a dashed line, so we're going to be using less than or equal to. Sorry, less than or greater than. I didn't mean to say both of those things. because the y-intercept is not really graphed where the solution is, we have to look at this piece and kind of draw arrows all the way along it. So is that shaded above it or below it? Above. So greater than. So then what would that inequality be? If we put all those pieces together? Greater than negative x or negative 1x minus 3. Alright, so we have our system of inequalities. Last thing, we just need a solution. So look at the shaded area that is overlapping. Find one point that would be a solution. This could be anyone. Someone give me one point that would be a solution in this. Sure. We did a lot today. We're stopping now. The next page, you'll see that there are calculator instructions. I haven't shown you that, but if you want to play around with that, you're more than welcome to. In Desmos, if you want to check yourself, just put in 2 equations. You don't have to solve them, and it'll show you what the 2 look like. So I'll put in the first 2 that you did. It will give you dashed and solid lines. It'll color it for you. You can change the colors. You can change the thickness of the lines, the type of dash it does, all of those things. And then you can start putting in ordered pairs and see does it fall in there or not. Okay, so you could be working on Khan Academy. More practice in the packet. So Khan Academy, let's do this week. Khan Academy from today, let's do next week. Practice from the packet. Let me know if you need